Okay, so good morning. Of course, you're aware this is our final review session, so I don't have like any new material planned. This is just a review. As a reminder, of course, this is a comprehensive exam, so it's over the whole semester. What you noticed on Blackboard, I gave you like a list of these other things we would emphasize. The study guide section, so I encourage you to take a look at that. And of course, you've done your homework as well, right? The homework was due last night, so it's really up to you. If you have something you want to make sure we talk about, we can talk about it. If you have no questions, specific questions on anything, we will transition to something I have planned. But it's up to you what you want to do this time. No one has any questions at all? Yes, Emma.
Well, I just have a question for the review. Is it going to be online if she like writes down the question? Like, what we're doing?
Oh, I mean, I guess I can post this online. I don't have an answer key for it,
Okay.
but I can post it online. Yeah. Any other questions? Okay, so what I've given you are these. I'm going to need one. Everyone have one of these? Now you want to grab one from there. These are, they have several names. Generally, they're called response cards. I call them clickers because that's what I'm used to. I used to do a version of this many years ago where they were like, they look different than these. But these are response cards. Has anyone ever used these before? I know a few of you have. A few of you have had me before. All right, okay, so if you don't know how this works, I'm going to put up a question on the screen. And let me select. You will then press the appropriate button. You know, and it's an A or B or C or D, it'll be a multiple choice thing. And it will receive it, it will count everything up. You won't see the results until I hit, until I end the polling, and it'll show the results. So we'll see the distribution. And typically what will happen is you will have some time to talk amongst yourselves to try to figure out what the right answer is. And then we'll repoll. So the whole point is you think of the question, you think of the answer on your own, and then you talk with someone, and then we discuss it as a group. It's called think, pair, share. I kind of got you. Cute little pair, share. On these, how these work, some people always want to know, if I select one thing and then I change my mind and select the other thing, what will happen? Well, the computer's smart. All of these have an ID on them. So if you say A and then you're like, well, actually I think it's B, and you hit B, it will move your vote over to B. So there's no concern about that. Also, too, don't be the person who wants to know if it hits. By the way, you can tell if you press a button, the light will go green. If it's red, it means it didn't get it. But if you're not sure it got it or not, you point at the screen, hitting the button. Don't be that. It's just a screen. It's nothing here. It shouldn't matter where you point, but if it makes you feel better, this is the receiver right here. Not this. This is nothing. So let's do some practice. This is a good time for me to get an idea on other things that are not covered by the evaluations, which again, I remind you are available on Blackboard. One of the things that official evaluations don't cover is how you get material from. So I'm curious, right? As you, of course, know, I maintain my own personal website that has lecture notes and everything available, course notes. And I also maintain that exact stuff on Blackboard. So I'm curious, which do you prefer? Do you tend to get it from my website? Do you tend to get it from Blackboard? Do you do equally between the two? Do you not use them at all? Did you not know they were available? I'm always curious to see the people who choose the G right there. Where do you tend to land? Oh, I should check. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 today. Okay. And 3, 2, oh, good, we got them all. Okay. Looks like they largely prefer my website. I need to fix my website. I need to update it. But why do you typically prefer my website? Something on my website. It's easier. Yeah, everything is getting up and log in. That's what I typically hear. For those of you who go to Blackboard now, at least more than half of you go equally to Blackboard on my website. Why do you sometimes go to Blackboard to get course material. Yeah.
Because I'm already logged in for another class.
Okay. So it's just a couple of clicks away.
Yes.
Is it so hard to hit dyover.com and then go to the website?
You can also just search your name.
Yeah. But apparently Elizabeth just wants to go there.
Well, I mean, like, it's just convenient. If I already have it open.
Understandable, yeah. Okay. Just curious. So I should maintain both of them.
It's really in that way for me, but I'll do it. Now, I have another question. So, the way that we
Do homework in this class is
it sort of irritates me a little bit.
and I've thought about changing it, but I want to get people's opinion on it. So the way we do it, we have, of course, our unit, and then we have the exam. The problem is, homework is due right here. Literally, it's due the day of the night before the exam, so 11:59 at night before the exam. The problem with doing it that way is because I give you multiple attempts, you can't see the answers until the day of the exam. So I've thought about changing it so that maybe we move it like so that it's due like the day before the exam, or maybe move it sooner. How do you feel about that? Do you prefer it due the day before the exam as it is now, or do you prefer to have it due 2 days before the exam? So in other words, if the exam is on Thursday, rather than it being due Wednesday, which is what it is now, it would be due Tuesday night rather than Wednesday night. And that will give you Wednesday to look at stuff. The problem is, of course, the material that we covered is Tuesday, so you'd have to do it that night. So there's a small window. So which do you prefer? Do you prefer it as it is now? Let's just do the day before the exam. Or would you prefer to do 2 days before the exam? So this would be option A. And this would be option. I'm sorry. This is option. Sorry. This is option E. This is option A. Or do you just start here? Three, two.
Oh, really? Interesting.
That was different last time I asked about this. I think I asked this again like last semester, was largely over on A. Why is that? So let's talk about that. Why do you want to prefer, why is it worth to you to go 2 days and have it due Tuesday? Yeah.
Because I guess we like ask questions in class to maybe go through a question and understand.
Well, it would be due Tuesday night.
And the test is on.
Exam is on Thursday.
Or I guess you could just go over it on the answers. So
Yeah, you would have all of Wednesday to look at the answer.
Yeah. Instead of just like knowing the answer, but actually like doing the practice.
Okay. Any other thoughts on this? Vast majority of you selected this. So for those of you who wanted it still on Wednesday, though, why did you pick that? Anyone? Anyone want to speak up as to why? And as the only one that's willing to voice an opinion about this, give me some detail. No? Well, given how strong he was, I'll see what the next section says, but given how strong he was. Okay. Well, I don't care either way.
Oh, is he leaving on the beginning?
I think the first time I put stuff on Blackboard, I had it like do at 10 o'clock at night rather than 11:59. So I thought, oh, well, then you have to stay up that late, and then you could like get it after 10. And that just confused everyone because they're so used to having to be due at midnight because all the classes work that way. Yes, just not responding at all. Not like that. You like that. No. Midnight's better. I guess you guys know. See, that's the other thing too. Is like I go to bed at like. Sometimes I go to bed at midnight, but other times I go to bed at like midnight is the latest I ever stay up. Usually, and usually I'm at like 9 or 10.
Do you know why I go to bed 9 and 10?
Yeah, because it was
Yeah, I had to wake up early this morning, and because my son goes to bed at that time, and he wants me to be in the bed with him. Because for some reason he wants to grab my hair. He will that's how he falls asleep, is he grabs my hair and squeezes it and then pulls on it. He's like 2.5. He's like 16. He's like 2.5. He's just a kid. But it's funny too because I'll fall asleep and then I'll leave, and then like 5 minutes later he starts screaming. Like, no, even though he's asleep. Like sometimes I can get away with it, and sometimes he like immediately knows.
That's like crazy.
Yeah, it's cute and annoying. Really cute, but anyway, that's all. I'm like, oh my goodness, midnight is so late. Like, why are you staying up past midnight? How many of you stay up past midnight to look at the TV? Oh, most of you do. Okay. See, I want you to go to bed earlier or something. Some people are night owls, I don't care. Okay, so that concludes my questions about the class. Does anyone want to cover anything in particular? Because I have lots of questions for you. What about 24? Yeah, Anna.
Well, there's just a question on the board where I couldn't get understand it.
I don't know what question it is.
Well, I don't know if you know. It's number 8 or 12.
Oh, I think it was the one you were talking about. It was about the sexism thing?
Yeah, I think the second part to one of them.
So remember how I mentioned in the beginning that
If you have a very small sample size versus the size of the population, you can use binomial. And then I said, like, when did I just use the binomial one? If you can do it, you should use it. That's what that was. Someone emailed me about that too. You should have just emailed me. I could have answered it. But yeah, no, that's what was going on.
I'll ask guys. Any other questions? Okay. Well then I have some questions for you. Oh, let's see. I have so many things. Let's go back. Let's do this one. What is the weighted average of the following data?
Of course, I have values here, and then I have the weight for each value, and then I needed a title, so I called it A, B, C, D. We have 3 respondents, 4 respondents. We have 17 of you now. So we have 2, 4, 6, 8, 10, 12, 14. Yeah, 17. Someone came in. Does everyone have one of these, by the way? I'm going to close polling in 3, 2, 1. Okay, so it looks like about 70% of you said C, but there's still a few people that are all over the place. So why don't you take a few minutes, try to find someone you disagree with, and try to convince them that you are right. Just a few minutes, and we'll do a recall and we'll talk about it. You agree? Did you agree on C? Okay. How did you get C? You would get 7.5, 6, etc. Yeah. Makes sense. What do you divide by? You don't have to divide by anything. Oh, no, why not? Because it's you should always divide by something. The weight is I multiply 100%, you will have 45. So what are you dividing by? 100%. Oh, 1. Yeah. So you don't divide. You technically are dividing. You're dividing by 1. You're all alone.
Yeah.
Have you talked to anyone? Have you talked to anyone? What do we do when you're angry? Yes. Did you speak to?
Yeah. No. No agreement on what? So why do we only have one response? So I'm doing a repoll to see how people change their mind. If you haven't changed your mind, you should respond to the thing. There we go. So then once we repopulate the responses, we can see how things are, and we can move on with our lives. Elliot, I got this for you. All right, and 3, 2, 1. Okay, hey, I love to see how it changes. So usually if it's a very high percent the first time with the right answer, I don't repoll. But it was high on C, but not really high, not super high. Well, it was super high, but not super duper high. So, but now you really gravitated towards C. Why is C the best answer? Okay, you all did it, so you can tell me how you got it.
It's surprisingly quiet for something that you just all did.
Value times weight, thank you. So that's going to be 7.5, that's going to be 0.6. That was 0.07 for the next one, and that is 2.8. And then you add them all up. By 11, and you get 11.6. What do you divide by? Saibo, what do you divide by? 1. Why do you divide by 1?
I don't know, that's what you said.
Was that correct? Exactly. If you add all the weights up at 100%. The only reason why I mention this is, let's say that we didn't have D. You didn't know that the value for D was 8. Then you would, if you did all this and then added it up, you wouldn't be dividing by 1, you'd be dividing by 0.65. And you would get a different weight. You would get a different answer. Because you wouldn't have this information. Any questions? Okay. Oh, that was fun. Let's do another one. That's boring. That's kind of boring. Oh, okay. Which of the following alternative hypothesis is an example of a two-tailed test? Try to answer it on your own without talking to anyone. It's more fun that way. So we have A, Billy's salary is lower than normal. B, based on pollution test, water isn't safe to drink. C, Carrie's ability to play basketball is very unusual. Or D, Yogi is smarter than the average bear. Three, two, one.
Okay. That's very nice. Now I'm getting 80% before sometimes I'm getting 80%. I'll say that is enough that we don't have to discuss it. Why is C the best answer? Why is C the alternative hypothesis is an example? Why is C that the best? Yeah. Yeah. Yeah, this is in retrospect pretty easy because they even use the word unusual. But I thought it was funny. Right. Her ability to play basketball is very unusual. Very unusual. But usually that's bad. But this doesn't have to be. Okay. Well, let's do this one then. Unusual start. Let's do this one. There. Suppose we have a sample of 16 kittens. They have an average weight of 8.7 ounces.
The population average is 8.5 ounces.
And a sigma of 0.45. Can we reject the null hypothesis that the weight of these kittens is normal? So imagine we have 16 kittens. Maybe we're curious. Oh, maybe they're a bit heavier than normal. Maybe we've been given a different diet. Or maybe they're growing in different environments. Or maybe their parents all had something in common. Can we reject the hypothesis? Of course. We reject it. Keep in mind too that for two-tailed tests, 95% z-score is 1.96, and for one-tailed test, 95% z-score is 1.645. Yes, no, can't be determined. I guess we're doing this 95% confidence. Yeah. We're doing 95% confidence. I didn't try to make sure that. So, 11 of the 18 now, 2, 4, 6, 8, 10, 12, 14, 16, 17, 19. Does everyone have one of these, by the way? Yes. Oh, see, there's a silver cannon light. And this is the sign-in sheet coming around. Those are cannon lights.
I want to close polling in a couple of minutes.
Close it in 5, 4, 3, 2, 1. 1/2. Okay, looks like we have a fair amount of disagreement. Time needed to try to find someone you disagree with and convince them that you are right. Almost half and half. Almost half and half. That's about as close as you can get with an odd number of people.
That's a great time to ask me. Oh well, we'll get some text messages. Oh, okay. That's fair. Oh, I'm going to reopen the polling. Reopen polling if you want to form it up your own format. So of course I reopened polling if you figured out what's going on.
Everyone reach the consensus? If you reach the consensus, put in numbers in, I'll give you a minute or so more. I'm going to close it in about 15 seconds so we can move on with our lives. And I will talk about it afterward. 5, 4, 3, 2, 1. All right. Let's see what it is. Okay. So it looks like we've moved slightly away from ASI toward B, which makes sense. That is correct. B is the correct answer. Well, let's talk about why it is. So this is obviously a simple test for hypothesis. How do we do that? What's the equation for that? I'll give you a hint, it's a z-test, right? Because we know sigma. X bar, mu, and we obviously have the absolute value, got to throw in there sigma divided by. Now, I wrote alpha here. Is this alpha, or should it be something else? Alpha divided by 2. Why is it divided by 2, Anna? The two-tailed test. Why is this a two-tailed test? Exactly, already normal. So, and you guys are like, oh, it's just easy, right? That previous question was a preview for this one. Absolutely, this is a test versus normal or not. Then it's just a simple matter of mathematics. What's the difference between x bar and mu? Well, I guess I could just I could put in the actual numbers for those. 8.7, 8.5 divided by, we have a 0.45 for sigma, and square root of 16 because we have 16 kittens. There we go. Does everyone get that? That's just simple. This is x bar is obviously the sample average. Mu is obviously the population average. Sigma is literally right there. It is right there. And then we just have a so this is how it simplifies. This is how it simplifies some more. You take that 4, put it in the numerator. And this is the denominator over denominator. And then this comes out to about, what does it come out to be? That's right, 1.778. 1.7 repeating. So what does that mean? Exactly. Many of you who said yes might have been thinking it was a one-tailed test. And if it wasn't a one-tailed test, it would be. But it's not. It's a two-tailed test. So not weird enough. Not unusual enough. Okay. Any questions on that? All right, let's do this one. Hannah's running a regression of school spending and economic growth. Using country data, she uses school spending per pupil to predict GDP per capita, or average income. If Hannah wanted to flip the causation, as in income causes GDP, as income causes school spending, could she determine the best fit line from the first regression?
A, yes, but you would have to flip the signs of the coefficient and intercept. B, yes, the numbers will be different, but you could just select the other variable and isolate it to get the new equation. C, no, because the vertical distance on the question has changed. Or D, no, because the horizontal distance in the question has changed. Or the horizontal distance in question has changed. Which of these is correct?
We have 19 of you. Everyone have one? Yes? Why is there not 4? Oh, okay, we're getting closer. All right, so let's roll in 3, 2, 1. Looks like we have a fair amount of disagreement. Time for you to try to find someone you disagree with and convince them that you're wrong. Oh, the math here.
Sometimes it's like, it's literally uniform too. Sometimes it's like literally everyone built the same thing.
Numbers are different, but the line shifts too. No, they're not gonna work on me.
I have 5, so I assume you figured it out. And I've heard people quieting down a bit on how much they're talking. So I don't know if you figured it out or not. If you still figured it out, keep talking. If you have figured it out, take your response. We'll see where we are. All right. In the interest of time, I'll give you, we'll say 1 minute left. Give you 1 more minute to figure this out. Three, 2, 1. Go ahead and please submit your responses. Please figure it out. I assume people are still. Right? Good? Okay. Most of you seem to submit something, so. Alright. So I'm glad we pulled away from A. A was just weird. You just changed the coefficient and the intercept. So you make the B's not negative, and then this one or positive, and then this one is also flipped like that. That's obviously not the case. So I'm glad that we pulled away from that. Most of you are selecting C. Why is C the correct answer? I will say C is the correct answer, but why is C the correct answer? Anyone? It appears like maybe 2 of you, I think that's 2 of you said D, 4 of you said B, roughly. Anyone? No one, most of you select C, but you have no idea why. Maddie?
It was a lucky guess.
It was a lucky guess. Usually the answer is C. Let's just try it. Let's see. So, let's talk about why you can't do that. Let's talk about why you can't do B, because B seems like the thing, like if we want to make this the Y variable and this is the X variable, why can't we just isolate this and now it's over there, and now, and then we'll have a new beta over here, we'll have a new beta 1 over there, and it's fine. But the thing is, this is found by minimizing the vertical distance between these two. So I tried to draw one kind of flat to illustrate this idea. If you flip it on an XY line, and you made the same line, then now this is the vertical distance. You see, this one's a lot bigger. Like that would be the new vertical distance. And there's no guarantee that this would match this. In fact, in all likelihood, it won't. The only way that this would match this is if the slope was 1. It's not going to be 1. It might, but it's not going to be 1. So you have to just rerun the regression, because then you'll get a new vertical distance. And that would then necessitate a new line. And we saw that. We saw that when we did the Rate My Professor data. When I noticed that when we had the causation run one way, you can see one observation was right on the line, but when we reversed that causation, that observation was no longer on the line. Well, if it doesn't matter, then if you could just solve for x, if you could just swap everything around, then that observation should still be on the line regardless. But obviously it was not, right? Because we had to get a whole new line. We have to get a whole new, because our vertical distances have changed. Any questions? And this is also to a reference of something that some people in the paper sort of forgot as well. When you are running a regression, you are making a causal claim. Right? That's why we care about the vertical distances, because we are trying to predict this value when you put the dependent variable on this axis, on the vertical axis. Some people kept talking about that these things should be correlated. It's like, no, you're making a causal claim. So you have to explain why one variable caused the other. Any questions on this? All right, let's start with something else. Some people have trouble with the number one. Consider this regression predicting adjusted SAT scores. Which variables are statistically significant? We have percent water, we have median income, and we have population concentration. Admittedly, I'm not sure what that is. I think it might have been my population density measure. I don't know what that is. Let's ignore that. We'll just interpret the regression. So we could have percent water, median income, population concentration, maybe only these two, maybe only these two, maybe only these two, or maybe all of them are statistically significant. We have lots of options. Which of these are statistically significant? I guess I should have a none of them option, but obviously at least one of them is. We don't have a none of them option. Should add none option. Three, two, one. Okay, it looks like we have some disagreement. We have some focuses, but we have some disagreement. So why don't you try to find someone you disagree with and try to convince them that you're right.
You might not remember, but they're going to be like, that's all I've read. Yeah, I see.
For those of you who have reached a consensus, I'm going around to see if anyone has any questions.
Every turn.
Consensus?
Yes, it's
Okay, so I've reopened the polling. If you want to go ahead and submit, I'm sensing based on the talk that you guys are talking about, like, I think that you're not, very few of you are talking statistics, so I assume a lot of you have reached a consensus. So if you can go ahead and someone was talking about surfing, I'm not sure. 50% water, maybe? I don't know. 3, 2, 1. Oh yeah. So, who's the one person, by the way? It's an A and B. So why is it F? Yeah, Trick.
F is population concentration that's below 0.05.
Mm-hmm.
Median income also below 5.
Exactly. So that's quite big. So exactly. I sort of hit it a little bit too. You see, it's not very wide. I can't remember if I did that on accident or on purpose. But I'm wondering if the person who selected median, the people who selected median income last time, were looking at standard error. Obviously, you shouldn't look at standard error, not just because it's not what you look at, right? You look at p-values, but clearly you're not supposed to look at standard error because this one's over 1. Right? P-values can't possibly be over 1. So, great. Any questions on that? All right, let's head into, we got like 15 minutes left. So, let's do, okay. I like this one. Suppose I construct a nerd test on the premise that nerds are good at math. This is my nerd test to get. But the now test is, what is 2 plus 2? What is 2 plus 2? Don't give away the answer, but that's not the question. My question is to describe the sensitivity and specificity of this test. So is it A, 100% sensitivity and 100% specificity? I should say 100% sensitive, 100% specific. 0 sensitivity, 100% specificity, 100% sensitivity, 0% specificity, or 0 and 0? I don't know a damn thing. Oh, 3, 2, 1, okay. Okay, most of you selected C. There's a couple of people disagree. Why don't we take like 2 minutes just to talk to everyone, just to make sure everyone's on the same page. And then I'll hit a repoll and we'll talk about it before we make sure
Specificity, don't I hear right now, you're not. So, don't give it right. It's negative, I don't want to actually help it. But it's help it. Did you confuse yourself? Don't scare me. It's not a
I'm gonna go over here. You both seem really quiet.
I'll start seeing why.
Alright, in the interest of time, I want to go ahead and shut this down, so if you found a way to confuse yourself, we'll talk about it.
I do want to move on to another question.
Three.
I'll give you let's give you 10 more seconds. Yeah, 10 and 10 seconds. But now there's only 5, 4, 3, 2, 1.
The 14. You know what? If you don't want to belong, you don't belong. Okay, so I agree. C is the best answer. You know, I'm a little annoyed that C was the best answer again. I might want to change this, reorder this, and make it be the right answer. Switch these two. But C is the right answer.
Why is C the right answer here? Because everyone goes to this.
Okay, so
That makes it 100% positive.
the what?
So the sensitivity is a test for being positive,
Mm-hmm.
and specificity is a test for being negative.
Mm-hmm.
So since everyone knows that 2 plus 3 plus 4 is 100% positive.
Exactly, yeah. Yeah, and I'm glad you brought that up, too. Under this scenario, if it's 100% sensitive and 0% specific, that means it's always going to be positive. The result will always be positive. Everyone's a nerd. Do you know 2 and 2? You're a nerd. Right. So that's another interesting aspect that Mosen's pointed out. But he's absolutely right that this is clearly, it's always going to detect a nerd, but it's never going to detect a non-nerd. So it's going to be rolling a lot.
Even if that's so possible. Any questions on that? All right. Let's do this one. Suppose 6% of employees have stolen a notable amount in their workplace.
A notable amount, I mean not stealing like office supplies, but something substantial. Suppose you have devised a test, which is 80% sensitive, 90% specific, about what is the probability that an employee is stealing, assuming the test comes back negative. This is probably going to be the last question we do because in all likelihood it's going to take you a while to figure it out. But we have 0.014, 0.338, 0.662, or 0.986. You can, of course, use the tree diagram to figure this out. Or if you really want, you can also use the, or you can use Bayes' theorem. I think Bayes' theorem is faster, but either one works. Bayes' theorem makes you only figure out the things you can figure out more.
the test is positive, then you are swimming. So it's basically asking, this one looks negative, maybe I'm wrong. Maybe you are swimming. There's a chance that even if the test comes back wrong, test comes back negative, you're honest. If the test is wrong, what's the chance of that?
I want to close call in about, we'll say, I don't know, we'll give you 15 more seconds starting now, and then we'll close call it. 10 seconds. 5, 4, 3, 2, 1. Okay, looks like we have a fair amount of disagreement. Now it's time for you to try to find someone you disagree with and try to convince them that you're right.
We got about 5 minutes of class left, so
Yeah. So have a quick conversation. I'm going to write myself on the board. You guys don't got yours.
I want this to be in blue.
Well, this is
It's either negatives or positives.
So in the interest of time, I'm going to ask you to wrap it up. So if you're not really sure what the answer is, your best guess, I'll put some information on the board here. We'll get our discussion. So I want to wrap it up. Show you the answer is and then conclude the course. My watch, we only have about 3 minutes left of class. So I'm going to close it in 10 seconds. 5, 4, 3, 2, 1, 0. Okay, so it still looks like we have a Fermat disagreement. Let's go through the math a little bit.
So we are testing what is the probability someone is stealing, assuming the test comes back negative. So naturally we convert this to Bayes, assuming what's the probability the test comes back negative, assuming someone is stealing, times the probability they're stealing. Saying the denominator was the probability that the test comes back negative, assuming someone is stealing, times the probability they're stealing, plus the other way to get a negative result, assuming the test comes back negative, assuming someone is not stealing, times the likelihood they are not stealing. So I took each of these 4 components, each of these 4 variables you see, obviously this one is pretty straightforward. This is the chance they're stealing, that's a given, 6% of employees steal. This one also straightforward, the chance that they are not stealing. When 6% are stealing, then that means 94% are not stealing. So that's straightforward too. This one is a little tricky. The chance that someone comes back negative, the chance that the test comes back negative, assuming they are stealing, is this test result correct or not? Is it correct? No, it's not correct. So that means, and is the person stealing or not stealing, is this a positive state or a negative state? Positive state, right? So that means we're looking at sensitivity, but the test was wrong. So it's not 0.8, it's 0.2. So when it's stealing, but the test came back incorrect, so it is it's incorrect, so it will be 1 minus 0.8. And then this one is simply specificity. The person doesn't steal. We can identify them as not stealing. The test is correct. That's 0.9 in specificity. And then we just do some math. So we have, I can't even read that. I can barely read that. Let's use the blue. 0.06 over there. That is 0.2. That's going to be 0.2, 0.06, plus this stuff, 0.9 and 0.94. That's 0.9 times 0.94. Let's actually do this math before we start. I got 0.846. So I want to make sure I did this right. That looks right. Right? If it was 2, then it'll be, so we lose decimal point. And then we take that plus 0.06, and we get 0.012 divided by 0.906. And that should be, if memory serves, .013. Which I think when I originally wrote this, this part right here. So this comes from this right here, right? And then these are the two different ways to get a negative test result. So immediately you can say about 90% are going to be negative. For some reason, I thought that was okay.
I thought you had 0.0 plus 0.856.
Oh, did I? Oh, you know what? Yeah, I don't know what. I did some math error right there. I think I put something in wrong. Oh, I see what I did wrong. Yeah, so that should be 0.858. Thank you. I was like, because that should come out to 0.14. Is that correct? Did everyone get that? And 0.858. Oops. 0.012 divided by 0.858. Yeah, I got 0.14. So A is the right answer. A is the right answer there. Okay. So that concludes the course. I hope that you got a deep appreciation of statistics, at the very least how counterintuitive statistics can be. It's hard for people to do statistics. We're not used to thinking in these terms of probability and uncertainty, at least in this way. But hopefully you got a little bit more intuition. I will see you next week for the final exam. Have a great weekend, everyone.